Good morning, guys. All right, so just moving along in our trig unit for Math 30-1. Topic 4.4 that we use in the textbook is called Intro to Trigonometric Equations. So we do this a bit in Chapter 4, then we kind of come back to it in a bit more in Chapter 5. We kind of solve these ones graphically, and then we kind of solve them in Chapter 6 some more as well. So this is kind of like part 1 of 3 for trig equations that we do in this course, okay? So first one, so just, first of all, guys, if we say solve an equation, it means we're looking for the variable. Okay, so in this case, the variable is going to be theta that we're trying to solve for. Okay, so first one, we have 2 cos theta plus 1 equals 0. Okay, so we're going to start solving this the same way that we solved like a regular linear equation, and we're going to try to isolate for cosine theta. So I'm going to subtract 1 from both sides, and then divide by 2. So we get cosine theta equals -1/2. Okay, so from here, I think the easiest way to do this is if you have a unit circle handy. And we have to know that on our unit circle, cosine is the x value on unit circle. So on our unit circle, -1/2 is one of the values that we have on a unit circle for x. So I'm just going to draw kind of a quick one over here. And hopefully we recognize that if you look at the unit circle, where does x equal -1/2? Well, it equals at here and here. This point was -1/2 √3/2, and that happens at 2 pi over 3, and it also happens at -1/2 √3/2, and this happens at the angle of 4 pi over 3. Okay, so just have your unit circle handy for this section because you're going to be referring to it a lot. Okay, so therefore, our angle theta equals 2 pi over 3 and 4 pi over 3. Sound good? Same idea for example B. So I'm going to add √3, divide by 2. That means we're going to get sine theta equals √3/2. And now the same thing, except sine is the y coordinate on our unit circle. And that's going to happen here and here. So this is happening at -1/2 √3/2 and at +1/2 √3/2. Okay. Now the idea here is that the domain we're given is only from -pi/2 to +pi/2. So from 0 to pi/2, I can go from here to here, and that's going to hit this angle here, which is pi over 3. And this is actually going to be our only solution, because if I go from 0 to -pi/2, it's going to be from here to here, and I'm not hitting this second value over here at all. Okay, so even though this one is on the unit circle, it's outside of the domain that we're given for this question, so that means this is going to be our only solution of theta equals pi over 3. Okay, for part C, we have 5 tan theta plus 5 equals 0. So I'm going to subtract 5 from both sides and then divide by 5, and that gives us tan theta. Let's do a couple more steps here. Equals -5. Divide by 5, and we get tan theta equal -1. So let's kind of think about what tan means again. Tan means y over x. So if we have y divided by x and the answer is -1, well, that means y and x are the same value, but one's positive and one's negative. So where does that happen on a unit circle? Well, it happens twice, and that happens here and here. So this point is -√2/2, √2/2. We're going from 0 to 2 pi, so this angle over here is 3 pi over 4. And happens here, where we have a positive √2/2, but then a negative y coordinate, -√2/2, and this is at 7 pi over 4. So our solutions here can be those guys right here. Okay, Example D, very similar to some of the other ones we've done. I'm just going to subtract by root 3, divide by 2. So we're looking for the x value of negative root 3 over 2. Happens twice here and here. This point is negative root 3 over 2, comma 1/2. And that's at angle 5 pi over 6. And this one is negative root 3 over 2, negative 1/2. And this is at 7 pi over 6. So our two answers are 5 pi over 6 and 7 pi over 6. Okay. For part E, we're going to do the same thing, add 3, divide by 4. And we'll run into something a little bit different here. The value 3 over 4 is not on our unit circle. Okay. So what we want to do in this case, so we have 3 over 4. The way we solve these ones in Math 10 and 20 is using our sign inverse button on our calculator. So remember guys, inverses, what they do in Math 30, well, not in Math 30, just in Math in general, inverses flip your input and your output values. So if I have this value, which is input, and this is an output, if I want to flip these guys, we're going to take the inverse function like this. Okay, guys, I'm just going to grab my calculator here. So we want this answer to be in radians. Okay, so you have to make sure your calculator is in radian mode. And we go second sine 3 divided by 4. And that means we get 0. All right, we get this. Now, a little bit, we need to be careful as well. This answer here is actually going to be what we call the reference angle for this guy. So what we see here was sine theta equals positive 3 pi over 4. Let's put i.e. sine is positive. We're going to apply our cast rule here. So when we look at this, CAST, which two quadrants is sine positive? Okay, well, it's positive in here, but it's also positive in the S quadrant here. So our reference angle in quadrant 1 is just going to be the same thing. Okay, so therefore theta equals 0. Sorry, I'm just going to go back for a sec. I think I gave round instructions. Round to the nearest tenth. Okay, so we're going to round to the nearest tenth for this question. I'm going to go 0.8. Okay, now what this does means is that the other reference angle, which is this guy over here, is also this value of 0.84806. So the way I get this angle, sorry guys, I'm putting arrows all over the place here, but this is going to be by pi, or 180 if I'm in degrees, minus my reference angle. I'm going to do this on my calculator as well. Second pi minus 0.848 equals 2.3. So our two solutions are going to be 0.8 and 2.3. Okay, so when the value is not on our unit circle, we have to go to like what I call the inverse and then the cast rule method. Okay, so the way I call it, like for solving trig equations, method 1, I say, is like look up the value on the unit circle if you can, and that's, I think it's generally quite a bit easier. But method 2 is if you can't look it up on the unit circle like we have here, we have to do the inverse like we did here, and then apply the cast rule to figure out what all of our solutions are going to be. Okay, we're going to have to do method 2 again. For example, F here, I'm going to subtract 1, divide by 2, and I get tan theta equals negative 1/2. Okay, so again, negative 1 over 2. We're not going to find this on our unit circle, or there's going to be no ratio of y over x on the unit circle values that's going to give negative 1 over 2. So we need to go and use our inverse. So I'm going to go tan inverse of negative 1/2 equals theta. Now, in this case, we want an answer in degrees. So I need to go and make sure that my calculator is in degree mode. When I do this, I get okay. Now, what's this negative mean? All the negative talking was the direction here. Okay, so it's giving us a direction, but we're going to treat this as a magnitude of this positive 26 as well. But if I'm looking at my CAST rule, 10 is negative, right? So let's put this in brackets here. 10 is negative. So which quadrants is 10 negative? Well, it's positive in A, so it's not in here, and it's positive in T. So that means we could be in the S quadrant or in the C quadrant. So if we're in the C quadrant, and this over here, going in this direction, is 26 point this guy, we need to figure out what's this angle here. So I'm going to put theta 1 for our first solution. It's going to be 360 minus 26.56 dot dot dot. Figure this guy out of my calculator. And that gives us an answer of 333.4. Okay. For the second one, we're in the S quadrant, and that means this guy over here. And so I'm going in this direction here, but that's going to be the 26.5 dot dot over here. So to get this angle, I need to go 180 minus my reference angle. And that gives me 153.4. So my two solutions are 333.4 degrees, and then we have 153.4 degrees as well. Okay, so example 2, similar ideas, but so in the first example is called linear trig equations. Now we have quadratic trig equations. Okay, so all that means for quadratic is like we have an exponent of 2, so that we're squared in here, so we have to kind of just be careful that we're doing the right things with our squared here. So first step, for this guy, I'm going to add 1. So we have cosine squared equals 1. And then to get just cosine, I'm going to square root both sides. The thing we need to remember, anytime we square root both sides of an equation, we have to go plus or minus our answer. Okay? So our solutions here, again, cosine is the x value, which happens here and here. So we're going from 0 to 2 pi. So this is like 0, and this is pi. And like 2 pi might have been a solution, but if you look at the domain, in this case, we're including 0, but we're not including 2 pi. Okay, so that means our two solutions are going to be, so we have 0 and pi are going to be our two solutions for this one. Okay, moving on to example B, same idea. I'm going to add 3, divide by 4. That means sine squared theta equals 3 over 4. I'm going to square root both sides. That means sine theta equals plus or minus root 3, and the square root of 4 is 2. So for this one, we have 4 points here. So this is 1/2 root 3 over 2. Again, sine is the y coordinates. So guys, for this part over here, you don't need to have this memorized like I do. Just use the unit circle you have in front of you. Just make sure you have it. And then just kind of pick off the values. You'll be able to see these 4 over here. So this is pi over 3. This is 2 pi over 3. This is 4 pi over 3. And we have 5 pi over 3. So theta equals And we have those four solutions right there. Okay, 3 tan squared theta minus 1 equals 0. So add 1, divide by 3. We have tan squared theta equals 1/3. Square root both sides. Square root of 1 is 1. Okay, now this one's a little bit trickier to see. Where does this happen on our unit circle? In the first quadrant, it is going to happen right here. If we go tan, which is y divided by x, is going to be 1/2 divided by root 3 over 2, which is the same thing as 1/2 times 2 over root 3. It's multiplied by the reciprocal. The 2's cancel out, and we get 1 over root 3. So this is happening at pi over 6. But we want plus or minus. That's also going to happen here, where we have negative root 3 over 2, 1/2, and that's at 5 pi over 6. It happens here at negative root 3 over 2, negative 1/2, which is 7 pi over 6. It happens here, which is root 3 over 2, negative 1/2, which is at 11 pi over 6. So we have four solutions, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, moving on. Example D, same strategy. We're going to add 1, divide by 2, and then square root both sides. I'm going to square root. That means sine theta equals plus or minus. We always have to do this for square rooting both sides. 1 over root 2. Now, if I rationalize this guy and multiply by root 2 over 2, we get plus or minus root 2 over 2, which happens 4 times on our unit circle. Happens here, 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 and here. So our angles are theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So those are going to be our four solutions for this guy here. Okay, example 3. So there's some more quadratic trig equations over here, but in this case, we have to solve them in a slightly different way. We can't just like add and then square root both sides. It's not going to work because we have one term that's a squared and one term that's not a squared only. So this term is a degree 2, but this term is a degree 1, so it's not going to work the same way we did the last one. The way we have to do this one is, this is going to be a bit of Math 20 review here, but the way we would solve this equation is to factor out an x, and that would be either x equals 0 or 2x plus 1 equals 0, which means x equals negative 1/2. Okay, so same idea over here, except we're going to factor out a common factor of sine. So that means either sine theta equals 0 or 2 sine theta plus 1 equals 0, and that means sine theta equals negative 1/2. Okay, so where does sine equal 0? That's the same thing as where does y equal 0 on this unit circle. Happens twice, happens here and here. Okay, so that means x or theta equals 0 and pi. For the second part, we have sine theta equals negative 1/2. Well, that happens here and here. Look at a unit circle there. So where do you find a y value of negative 1/2? That happens at 7 pi over 6 and 11 pi over 6. So here are the four solutions for that guy right there. Part B, 2 cosine squared theta plus cos minus 1 equals 0. We're going to factor this way the same way that I would have solved this guy. So this was like the Math 20 question. How do you factor and solve this quadratic equation? And this factors to this. So 2x times x is 2x squared, plus 2x minus x is plus x, minus 1 times 1 equals 0. So for this up here, guys, there's like a bunch of different techniques to factoring. Some of you guys may have done like the area model where you're drawing grids. Some of you guys may have learned decomposition. Some of you learned guess and check. That's what I was doing over here, okay? But no matter how you factored this, okay, really we don't care the technique you use. We just care that you can get this answer over here. So that means either 2x minus 1 equals 0 or x plus 1 equals 0, and that means x would equal 1/2 or x would equal -1. Well, same exact idea for this, except instead of having an x, we have a cosine theta. So this factors to 2 cosine theta minus 1 times cosine theta plus 1 equals 0. Don't forget the equals 0 here, guys. If this is like a diploma exam and you forget this part, it's not going to go well for you. Like that, they might take off everything, because the equals 0 here is definitely important. So we get cosine theta equals 1/2, or cosine theta equals -1. Quick little unit circle here too. Where does cosine equal -1/2? That's the x value. It happens here and here. That means theta, this happens at 2 pi over 3. And 4 pi over 3. Cosine equals -1. That happens at this point over here, which is at pi. So there are your 3 solutions for this guy here. Okay, part C. Same idea. We have to solve this one by factoring. So we're going to get cosine theta plus 2. And we have cosine theta minus 1 equals 0. So based off this, it means that cosine theta equals -2, or cosine theta equals 1. Okay, now looking at this one over here, cosine theta equals -2. This is not on a unit circle. If you try doing this on your calculator, cos inverse, I'm going to do this on my calculator right now, second cos -2, the answer you see on your calculator is error domain. This is on the TI-84 calculator I was using here. It's error domain. And why does it say this? Okay, this is not the answer you should put. The answer you put is going to be no solutions for this one. And here's why. If you have a cosine value of 2, the same thing as 2 over 1. So suppose that this is our angle here. If you have a cosine value of 2 or 1, this means this is the adjacent and this is the hypotenuse, or x over r. That would be 2 over 1. Now, if you look at this triangle, do you see how this is impossible? If this is a right triangle, the hypotenuse, or the radius, it has to be the longest side that we have, right? But in this case, we're saying this guy. So this is like an impossible triangle, and that's why this is not going to work, okay? So the answer you should put, if you have something like this, so the idea is like for your cosine and sine ratios, they always have to be in between -1 and 1. If they're not, say with -2 is outside of that range, we need to be able to say that there's no solutions for this root to the equation over here, okay? And the other one, cosine theta equals 1, where does that happen? Just once here. So our only solution is theta equals 0. Okay, all right. Tan squared minus 5 tan plus 4 equals 0. So we're going to factor this guy, and it goes tan theta minus 4, tan theta minus 1. Now, here, it's So we're going to get tan theta equals 4, or tan theta equals 1. Now we're going to see it is possible to have a tan value that's bigger than 1. Okay, so if this is my angle here, and tan is y over x, or opposite over adjacent. If this was 4, this was 1, well, this is definitely possible. I could have a 4 here and a 1 here, so that's okay. This is still not on a unit circle, though. So I want to go tan inverse of 4. Oops, so I want to be in radians for this one here. So when I just did it, I did it in degrees. So when I do this, I get 1.325 and a few more decimal places after this. But we need to remember, anytime we do the inverse method, we have to apply our cast rule. Okay, and cast rule, so tan is positive in A and T. So that means we're not in these two quadrants. That means angle 1 is 1.3. Our second angle is going to be this guy over here. Well, sorry, this is our reference angle of 1.3. But this angle here is going to be pi plus 1.325 dot dot dot. And do this on your calculator, and we get 4.5. Okay, the last one, tan equals 1. This guy is on a unit circle. Well, kind of, because this means that x and y are the same thing, because tan is y over x. So if tan equals 1, that means here and here, we have root 2 over 2 comma root 2 over 2. So if I divide those, I get 1. Here, we get negative root 2 over 2 and negative root 2 over 2. These two solutions are going to be pi over 4 and 5 pi over 4. All right, example 4. Give a general solution in degrees and radians to each equation. Okay, so this is for the first one over here. We just have a linear trig equation. So I'm going to subtract 1, divide by 2. Which happens here and here. So in degrees, this is at 7 pi over 6, and this is at 11 pi over 6. If I'm in degrees, this would be 210 degrees or 330 degrees. Okay, now what we mean by general solution, in the previous examples, we always gave you a restricted domain. It was usually from 0 to 2 pi, or from like pi over 2 to negative pi over 2, or some domain like this. But if we say a general solution in degrees, that means there's no restriction. Okay, so what I mean by that is that if I get here, this is one solution, but so would this be. If I go all the way around the circle and like this, okay, and so forth and so forth. So the way we're going to write this one this is how we write all the solutions from 7 pi over 6. But I'm just going to keep on adding 2 pi n. So if n is any integer, this is going to give me all the multiples, all the trips around the circle plus 7 pi over 6. It's going to take me down to this terminal arm all the time. Theta 2 would be 11 pi over 6 plus 2 pi n, where n's an integer. Okay. Now, we said in degrees or radians, so if it was in degrees, I'm just going to put like, or 210 degrees plus 360 degrees n, where n is an integer, and this guy would be 330 degrees plus 360 n, where n is an integer here. Okay, so this is how these general solutions are going to work for this guy. All right, 2 sine squared theta plus sine theta minus 1. So we're going to have to solve this one by factoring, and this factors 2. Okay, sine theta equals 1/2 happens here and here. Sine theta equals -1 happens here. Okay, I'm going to do this question in degrees first because I think it's a bit easier to see. Here's what the general solution for this one's going to be. And I'll explain what this means in a second. It's going to be 30 degrees plus 120 degrees n, where n is an integer. Now, why am I putting plus 120 n here? If you look at these three values, if I go 30, if I add 120, I get 150. If I add 120 again, it takes me to 270. If I add 120 again, it would take me to 390, which is the next coterminal angle for this guy over here. And if I add 120 again, it would take me to 510, which is the next coterminal angle here, and so forth. So the pattern here is these three angles are all 120 degrees apart. So I can simplify this and make a simpler general solution written like this. Same thing if I was in radians. 30 is the same thing as pi over 6. And 120 is the same thing as 2 pi over 3. So in radians, my solution would look like this. 2 cos squared theta minus 1 equals 0. This is a very similar question over here. Add 1, divide by 2. We have cosine squared theta equals 1/2 square root. And if I rationalize, so I think we've done this example already in this notes, but we get plus or minus root 2 over 2. This happens here, 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 and here. This is 45. This is 135 degrees. This is 225 degrees. And this is 315 degrees. What you want to notice between these guys is they're all 90 degrees apart. Plus 90 takes me to here, plus 90 takes me to here, plus 90 takes me to here, and so forth. So my general solution is going to be 45 degrees plus 90 degrees n, where n is an integer, or if we're in radians, we get those guys. Okay. All right, guys, it's been a long lesson, but here is the last one for example D. I'm going to add 3. Tan squared equals 3. And that means tan equals plus or minus square root of 3. I'm not sure if we've done this one yet, but where does tan equal root 3? If you look at this point, which is 1/2 root 3 over 2, tan is y divided by x, so like root 3 over 2 divided by 1/2 is the same thing as root 3 over 2 times 2 over 1, cancels, and that equals root 3. Okay. So where does tan equal root 3? Here equals negative root 3 here, and these guys. So this point is 60, 120, 240, and 300. Okay. Pattern's going to be a little bit different from this one. My first thought would be like, these guys are 60 apart, but they're actually not. So these two are 60 apart, but then these two are 120 apart. Okay, these guys are 60 apart, but then these guys are 120 apart as well. So it's not going to work like that. But if you look at these two are 180 degrees apart. So I'm going to put like theta 1 equals 60 plus 180 degrees n. So I'll go plus 180 and then plus 180 is going to take me back to these two guys over here. Theta 2 is going to equal 120 degrees plus 180 degrees n. So there's our two general solutions in degrees, and if I was in radians, it would be pi over 3 plus pi n, and this one is 2 pi over 3 plus pi n. All right, guys, I know that was a lot of information, but these questions take a lot of practice for you guys to be able to get good at these ones and be able to do them. Because I know there's a lot of different types that we've seen in this lesson so far. And as we keep going, when we get to chapter 6, you're going to see even more types as well. But I mean, these skills are very, they're kind of foundation for the stuff that we're going to be doing later on in chapter 6 as well. So we need to be really good at this stuff over here, okay? If you guys have any questions, please send me a message, and I will see you in the next video.